And from here, it makes sense for us to address an issue that we haven't thought about yet. If we look at this solve right here, you'll notice that all of this density is dissipating really quickly. We actually don't have a lot of smoke hanging out here in the simulation. And so this is maybe kind of a subtle thing that you won't pick up on right away, but there is something you need to know about the gas repeat solver that's causing this thing to disappear quickly. So let me tell you what I'm talking about here. Again, we have the gas repeat solve, right? It's this guy. Gas repeat solver. It goes through and it makes the calculation multiple times on whatever's above it. So that's good for advection, right? It's good for advecting velocity, advecting all the other fields that we want, temperature. If we have collision, then we want to bring that in as well. So collision and collision vel. And pretty much most of this is what we want. However, there are certain areas that we do not want to calculate 15 times in one step. And that's going to be related to these forces. So these forces coming in on the fourth inputs, that's what that 4 means that it's everything from this guy. And if we follow that string, we'll notice that we have turbulence, shredding, disturbance. And this all correlates with the settings we have here in the shape tab. So right now, if I was to, let's say, add some turbulence, well, I would add that in, and let's just follow the tree here. It goes down, hits the smoke solver, fourth inputs, goes through here, and gas repeat solver kicks in. Guess what? It's going to be thinking about that 15 times, which we don't want that to do. So we have a node that's going to help with this. It's called a gas intermittent solve. And this guy right here is basically allowing you to only do one calculation per time step with this option up here. So if we check that on, anything above this node will ignore the multiple attempts of the gas repeat solver. Now, the question is, where do we put this? We actually don't want to put it underneath this forces too. We need to calculate buoyancy, viscosity. We need to build the collision mask at each time that this goes to solve again. So what needs to happen, what I found, is that we need to go to the very top here. And the thing that we do not want to solve multiple times is going to be our forces on this fourth input. So that would be our buoyancy, that would be our vortex confinement. If we had turbulence, or if we had really anything that is a normal gas microsolver there to affect the forces, then you do not want to do that 15 times within a given step. So let's paste that right there. You also need to be careful because this collision source needs to be read in at every single time that the gas repeat solver is trying to do its thing. If you don't do that, then it won't recognize the collision more than once. So definitely do not put this guy underneath the collision source. Instead, let's create a merge node. And we'll basically take all of our gas intermittent solve stuff right here, and then our source can go right over there. So we end up with a situation like this. So all of the intermittent solve stuff now goes here. This guy does get the 15 rounds of calculation. And if we look here at our pyro solver, we go to our shape tab. We do not want to use anything here, because if we go to our fourth inputs, there's our forces. That also includes disturbance, shredding, turbulence. And also, if you have dissipation, then that is considered to be part of the sourcing and not actually part of the forces over here. So for all of those reasons, you do not want to use anything here in the shape tab when you're trying to do this gas repeat solve method. Hopefully that all makes sense. And one last thing about this guy is that it needs to exist above the gas substep. Otherwise, you're going to be repeating your substepping, which is not ideal. Let's also merge in a gas dissipate because we're not using that in the pyrosolver anymore, right here. So the gas dissipate is going to evaporate at 0.1. We do have this subtraction rate that we can use, but I'm not going to worry about that for the time being. We can always dial that in later, but just for right now, 0.1 ought to be fine. Also, I should mention that since the last video, I've added this gas vortex confinement. And just as a review, that confinement will boost the swirly motions. So the buoyancy hits, we have that up and down thing going on a swirl, right? That creates kind of this sort of motion. That confinement boosts the swirls and keeps them around for longer. So I like having that after the buoyancy. Buoyancy does its thing, it starts swirling around, and then we boost it right here. Besides that, velocity is at 60. We're adding that in at each step. Let's see what happens when we do a play blast. All right, and this is what we have. So this is a blob that looks like the original shape of our blob. So it is taking on that traced shape nicely. The velocity is pulling everything apart in the right directions. That's what's giving us that shape. But this is very, very poofy. And there might be situations where you want to be more directional with those poofs. I'll teach you how to unlock these magical powers in the next video.